Hello everyone, there are few methods we can use to lighting our scene. This video we will try the old method but still working perfectly. We will use GPU Lightmass developed by Luoshuang. In this scene I use Unreal 5.3 with GPU Lightmass that is available for the Unreal version. If you look at the result, the shadow is working great. The contact shadow between floor and objects on it are perfect. Before we lighting our main scene, I always use sample scene to test the global illumination. So if you are really curious how to implement the GPU Lightmass, first open new browser and type Luoshuang GPU Lightmass. Then open the Unreal forum about the topic. You can read carefully on it if you have a lot of times. Next, open the GitHub link provided for the Unreal 5.3. From the top menu, click on the code green button and select download zip. I will provide you direct download from this video description. Next, extract the zip file. Open the folder until you find a folder called engine. Right click on this folder and select copy. Next, open your Unreal 5 root installation until you find the engine folder. We want to put the file we copied before on this folder. Select replace the files. Don't close the Unreal root first. Open the engine folder. Inside the config folder, open the file called baselightmass.ini in your code editor. Scroll down to the bottom until you find div option GPU Lightmass. This section we can use it to control the quality of the lighting when using the GPU Lightmass. For the preview quality, let's adjust the num primary GA sample to 16 and for the num secondary GA sample, set it to 8. After done, save the file. For the testing scene, I'm using our updated master file from the previous part. Next, open the project settings. To use the GPU Lightmass, we need to disable some features like Nanit and Lumen, and some more features that support the Lumen. Scroll down to find the rendering menu. On the top right side, click on the export button to create a backup of this rendering section. Create a new folder on your drive called backup setting, and we will save the rendering backup on this folder. Click on save button to save it. Now click on the import button to import a new setting that I have already provided. Select the rendering backup from the list. Then click open. If we type Lumen, it is already disabled. Type Nanit and make sure it is disabled too. Scroll down to platform section and find Windows menu. Disable the SM6 and enable the SM5. Default RHI, set it to default. Next, press the Restart Now button. After we restart the project, we find that the 3D environment become white. Don't panic. We just need to adjust the exposure of the post-production volume. Enable the exposure compensation. Min brightness, set it to 0.5 as well as max brightness. On the empty area, right-click and select a new folder. We call the folder GPU Test. Open the folder. Next, we want to enable the Datasmith import plugin. From the edit menu, select plugins. Type Datasmith on the search bar and enable the Datasmith importer. Then press Restart Now. After we restarted the project, inside GPU Test, right-click and select New Folder. We call the folder Scene Test. Right-click on the empty area and select Level. Let's call this level GPU Test. Double-click to open the level. Press Save Selected. This is an empty level. Next, we want to import the Datasmith file. Then select the Datasmith file I have provided. Then click Open. Select the GPU test folder we created. Under the folder, select the scene test. From the datasmith option, enable material and texture, expand the advanced option, then follow the setup and press import. From the lit button, change to unlit so we can see the scene. From your keyboard, press Alt with 0. This will show us the light map intensity. Blue color indicates that our light map is in low resolution. Navigate your camera to interior area. Select the floor object. From the detail panel, type light. Enable override light map and increase the light map intensity. Set it to 1024 first. For the light map value, we need to use the power of 2. It starts with 64 times by 2 and so on. If we continue to multiply it by 2, we will get the different value, and the maximum value that we will be using is 4096. For the floor, we need to set it to like 2048 to make it high quality. Next, select the ceiling and increase the value to high resolution, something like 2048. Open the outliner tab, select all walls geometries. Go back to detail panel, enable the override light maps and set the value to 256. It will make all wall become green. Go back to outliner and select all frames of the windows. Go back to detail panel and do the same thing. Increase the intensity of the light map. Go back to outliner and select all object elements. Go back to detail panel and do the same thing. For this small object, we can use value like 128. Now we have done to set up the light map resolution. Next, open the world settings, expand the advanced section, change the shadow map texture size to 4096. Next, we want to add a skylight for our primary global illumination. From the detail panel, reset all position and location of the skylight to default. Change the mobility to static. Change the source type to specify cube map. Next, open the GPU test folder. Here I have provided a sky texture. Minimize the window, drag and drop the texture to GPU test folder. Double click the sky texture. MIP gain settings, change to no MIP map. Save the texture. Select the texture. Click on the arrow button to apply the texture. Select build menu on the top and lighting quality, set it to production. Next, we want to add Lightmass important volume. Change the view to top. Move the Lightmass element to center, then adjust the size from the detail panel. Make sure to cover all area. This Lightmass important volume will improve the lighting quality inside the room. So don't forget to include it when we use the GPU Lightmass. After done, go back to perspective view. Next, open the task manager. Open the performance tab and select our GPU. Change the GPU visualization from 3D to CUDA so we can monitor if the GPU is working or not. Please don't close this file because we want to adjust it later. We have already set it to low quality. To start building the lighting, select the build menu and select build lighting only. If everything is working, the GPU Lightmass progress will visible. Let's also check the task manager. As you can see, the graph is increasing. Our light build have completed. Just minimize the window. Press Alt and 4 on your keyboard to see the result. Let's increase the field of view a little bit. Now let's add a post-production volume to control the exposure. Change to top view. Move the post-production. From the detail panel, look for bound and enable the infinite extent. Go back to perspective view. From the detail panel, type exposure. Enable the exposure compensation. Enable min and max brightness. Change the value to 0.5 for both. To make it more brightness, lower the value. Press Alt and 6 to see the lighting only. And press the button again to change the lit mode. If you want to increase the quality, we need to adjust the base Lightmass file. Num primary GE sample change to 125 and num secondary GE sample change to 64. Then save the file. Save all the changes and let's rebuild the lighting. At the bottom right of the taskbar, it shows 10 EM. Let's see how long it takes to finish the light build. It took about 10 minutes to finish the light build. Let's check the result. Let's disable the ambient occlusion of the post-process volume. From the detail panel, type ambient occlusion. Enable the intensity and radius and set the intensity to 0. From the result, I think the lighting quality is perfect. The contact shadow also looking good. Decrease the intensity of the minimum brightness and maximum brightness to make it more brightness. Okay everyone, that's all for this video. Thank you for watching. Don't forget to subscribe and see you in the next video.